question, we're going to have a look at using this specific small angle approximation to show the left hand side can be rewritten as the right hand side. So straight off the bat, we want to replace both of these terms with this approximation. 4 cos theta is what you get when you multiply, so we can say it's approximately 4 multiplied by everything on the right hand side of this equation. So 4 multiplied by 1 is 4. 4 times theta squared over 2 is 4 theta squared over 2, which then simplifies to 2 theta squared. So let's rewrite this as minus 2 theta squared. Perfect. Moving on. Cos squared of 2 theta. What we're going to need to focus on first is just finding cos of 2 theta, because that's the challenge itself. What's happening here is you're replacing the angle theta with 2 theta. So let's do that to the right hand side of this equation. So it becomes 1 minus 2 theta all squared divided by 2. Now here, when you have a bracket squared, you square every term in the bracket. So this is 2 squared, which is 4, and then theta squared. So we have 1 minus 4 theta squared over 2. And then 4 divided by 2 is just 2, so you can write this as 1 minus 2 theta squared. But there's another catch. We're squaring this, so that means we have to square this whole term. Whenever you square a bracket, that just means you're multiplying that bracket by itself. So I'm just going to rewrite it out as 2 separate brackets multiplied by themselves. 1 times 1 is 1. 1 times minus 2 theta squared is minus 2 theta squared. Same here, minus 2 theta squared times 1 is minus 2 theta squared. Those will collect like terms to give you minus 4 theta squared. Minus 2 times minus 2 is 4. Theta squared times theta squared is theta to the power of 4. So that's plus 4 theta to the power of 4. Now we can join these together. So let's do this in a different color. Because what it's asking us to do is this. Oops, sorry. This plus this, which is this plus this. Collecting like terms, 4 plus 1 is 5, minus 2 theta squared, minus 4 theta squared is minus 6 theta squared, and lastly we have the 4 theta to the power of 4, and that matches exactly to what part A is asking us for, so we can move on now. I'm going to change the pen color because this color is quite faint, but in part B of the question, it's asking us to use this approximation here to find the value when theta is 3 degrees. A little trick here. You always want to deal with the angle theta in radians. So how do you convert from degrees to radians? You actually multiply by 180 over pi. So we take this angle of 3 degrees and you multiply by 180. Sorry, other way around. You multiply by pi over 180 because you're getting smaller if you're going into radians. Yeah. Sorry, I'm a bit distracted. 3 over 180 is 1 over 60, so this is like pi over 60 radians. And that's what you substitute into this formula here to find an approximation of what this whole function is when theta is 3 degrees. So putting 5 minus 6 lots of pi over 60 all squared plus 4 lots of pi over 60 all to the power of 4 in your calculator will give you the correct approximation here. Remember to put your calculator in radians mode, by the way. If you'd like a recap of how to do that, in my calculator, shift menu 2 angle unit and 2 radians. And I'm just going to put all this into the calculator now. Just one moment. If you like the answer, just skip ahead 10 seconds. 4 lots of pi over 60 all to the power of 4. And that will equal 4.98. That's your final answer to this question. So I'm just going to write that out. If you have any questions with that, please let me know in the comments. Otherwise, thanks for watching. Be sure to subscribe. I'm going to post a new video every single day. And like the video if you enjoyed it, just so I know to post more on this topic. Or otherwise, I've linked my email in the description too. If you have any tutoring inquiries, be sure to reach out.